This recording is to help you with Lesson 2.02, Polynomial Functions of Higher Degrees. Okay, we're going to start with the leading coefficient test and determining the end behaviors of your graph. Now, if your degree, your highest degree here is an even number, then your graphs will either rise together or fall together on both ends. If your degree is odd, your ends will do opposite things. Now, how do you know whether it's going to rise or fall? That depends on the leading coefficient, which is that number out in front. Because this is positive, I know that my ends will rise together. If that would have been negative, I know that my ends would have fell together. So here the degree is 2, that's even. That means the graph rises to the left and it also rises to the right because that coefficient is positive. The next one, to find out the zeros of a polynomial function, you're going to either have to try to factor or to use the quadratic formula. So here, because it's t squared minus 6t plus 9, I know that factors into t minus 3 times t minus 3, or we can represent that as t minus 3 squared. If I set that equal to 0 and solve, I will get t equals a positive 3 each time. The next one, we're going to graph and try to find the x-intercepts. Remember, your zeros are also called your x-intercepts, and that's where it crosses the x-axis. So for this one, we can graph it, and we get the graph below. Notice that it never crosses the x-axis. So therefore, we don't have any real zeros. We would call those complex answers. But because it asks for where it crosses the x-axis, we don't have any answers for that. So no real zeros would be our response. All right, and the last thing we're going to touch upon is what happens if I had the zeros. How can I work backwards to come up with an equation for that? Well, we know that x equals 1 plus the square root of 3, and x equals 1 minus the square root of 3. So let's just get everything on the same side. In my first one, I would have to subtract 1 and subtract the square root of 3. In my second one, I have to subtract 1 and add the square root of 3. So now everything is on the same side. We are going to then distribute. So you can use the distributive property 3 times here, or you can kind of regroup it like they did. I'm going to go ahead and just distribute 3 times because that's probably what we're more familiar with. Remember, the last step is the square root of 3 times the square root of 3. That's the square root of 9, which is just 3. Okay, I'm going to see if I have any like terms here that might cancel out on me. No other x squared, so I leave it that as x squared. I have a minus x and a minus x, so that's a minus 2x. Okay, a plus square root 3x. And a minus square root 3x, so those cancel out. I have, let's see, a minus square root 3, a plus square root 3, so that is gone. So that leaves me just with the plus 1 minus 3, so that would be a negative 2. So here's the polynomial that we can come up with to get the zeros of 1 plus square root of 3 and 1 minus square root of 3.